Good evening to one and all present here. I am Dr. K. Kannan, Assistant Professor, Department of Computer Science, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. Today we are discuss about in advanced RDBMS, Relation Database Management System. Today we are topic discuss about mastering log management in databases. This for Ajanta, mastering log management in databases. First of all, introduction to log management, and we are discuss about what is all deadlock and deadlock detection and deadlock prevention, deadlock avoidance and deadlock resolution, impact of deadlocks and log timeout settings and two-phase locking and deadlocks and the best practice in log management. Then tools for deadlock monitoring and conclusion. First of all, we are discuss about what is the introduction to log management. The definition of log management. The log management is goes to the database transaction, how to safely to access the shared resources without the compromising the data integrity. Then what is the role in concurrent access? It regulates the integration, the concurrent transaction, the concurrent, which means the duplication or transaction, the preventing the conflict that might the cause of data, the inconsistency, and ensuring the data integrity. Through the effective log management, the database maintain how to accurate the information of simultaneous transaction activities through the ensuring the data integrity. Next one is what is a deadlock? The deadlock, it is a understanding deadlock, and deadlock occurs the transaction is called manually, mutually needs the logs, the preventing any from the proceedings and causing the infinite definite of weights and the illustrate of transaction interaction deadlock scenario, the exemplifies of interactable the weight condition where transaction is cyclically block each other the progress, the impact on the data in performance. The deadlock is significant degrade the performance, the loading some increased transaction timeouts, the reduce the overall system throughputs. Next one is the deadlock detection. The deadlock detection is effective detection. They involve some algorithm identification from some of the conflict of this transaction, the monitoring and analysis, and wait for the graph. The wait for the graph visually the present the transactions dependencies illustrating the locked resources and facilitating and quick deadlock identification and cycle detection algorithm. The algorithm employed the graph detect the cycle indicates a deadlock, the triggering the appropriate resolution mechanism promptly. Next one is deadlock prevention. There are three prevention. The first one is resource ordering protocol, the avoiding the circular weights and the transaction timing policies. The resource ordering protocol is the ordering of all the allocation, the minimize the potential of conflicts, the leading the deadline scenarios, establishing for all the ordering the simultaneously allocation of conflict, the deadlock, the scenarios. Next one is avoiding curricular weights. In this implementing this protocol, the prohibits of circular weights in crucial for avoiding the deadlock situation entirely, and the transaction timing policy. It is priorities of rules based transaction timing can prevent the resource and condenser and subsequent of this deadlocks. Next one is deadlock avoidance. their algorithm, we are using the banker overview algorithm. This algorithm is allocate the resources, the safe and state of mitigating the deadlock before that can occur. And the safe, the state concept, a system is safe state when all transaction can complete without the leading to the deadlocks. The transaction, it will be a complete without the leading the deadlocks. And resource allocation method, this algorithm is computes the maximum needs the current allocation, ensuring a sustainable and resource distribution among the transaction. Next one is the deadlock resolution. There are three types of transaction rollback, resource preemption, and wait and die and own wait schemes. The transaction rollback is it locks, is allowing the transaction to proceed resolve the deadlocks. And the preemption, it is retrieving the resources it from the transaction to allocate then another relieving the blockages. And wait and die of wait schemes. The scheme that manages transaction, it is a priorities determining which one should be the rolled back or allowed to the wait. The impact of deadlocks, the increase the wait times. Next one is the transaction rollbacks and the service downtime risk. The increase the wait times, it is a prolong the transaction is wait times, they severely impacting the overall responses time and user the experience. And the transaction rollback is the frequent of transaction is rollbacks due to the deadlock can lead to data inconsistent and increase the overhead cost. Next one is service downtime risk. The presence of deadlock elevate the risk service downtime. It is disturbing the operational continuity and stakeholder of the trust. Next one is locked timeout settings. The lock timeout setting, implementing the lock time settings automatically terminate the prolonged the transaction. They reduce the during some of the deadlocks and occurrence. And next one is the dynamic adjustment of timeout. It is adapting the log timeout dynamically based on the workload, the patterns, enhance the responsiveness and minimize condenser of the issues. The best practice implementation, the integrating the best practice of timeout of configuration ensure the optimal database performance while safeguarding against deadlocks. Next one is what is the two-phase locking and deadlocks. And the two-phase locking mechanism, the growing the occurring the locks, the follow the splitting of phase of releasing them. Some potential of deadlock, the transaction is cold locks while waiting for others, and